Hi everyone. Let's take a look at the following example. Find the antiderivative of sine x to the power 4 times cosine x to the power 5 with respect to x and evaluate this from 0 to pi divided by 2. Step number 1. Recognize that the exponent is odd. So when you think about cosine x to the power 5, 5 is an odd number, which means you can rewrite this as the antiderivative, again, from 0 to pi divided by 2. You can copy sine x to the power of 4. When you think about cosine x to the power of 5, break this apart. So for example, we can think of it as cosine x times cosine x to the power of 4. And of course, that is the same as thinking cosine x to the power of 2 in brackets square. And again, this is going to be with respect to x. Now, if you look at this carefully, the goal here is to rewrite this in terms of cosine x and sine x. And what we mean is this. Again, it's going to be the antiderivative from 0 to pi divided by 2. Instead of writing cosine x squared, we're going to rewrite this as 1 minus sine x squared. So again, you can copy sine x to the power 4. You can copy cosine x, but now in brackets, instead of cosine x squared, it's going to be 1 minus sine x squared to the power of 2. Again, you're trying to find the antiderivative with respect to x. Now, if you expand this, look what happens. You can continue with, again, the antiderivative between 0 to pi divided by 2. I'm going to bring cosine x to the front this time, and I can still copy sine x to the power of 4. But now if I expand the perfect square, that's going to be 1 minus 2 sine x squared plus sine x to the power of 4, which I'll put in a set of brackets. And again, this is with respect to x. Now, look what happens. This is key. You want to expand this in such a way that you get the antiderivative evaluated from 0 to pi over 2. Again, you leave cosine x at the front. But if I expand everything else, which I'll put in a bracket, that's going to be sine x to the power of 4 minus 2 times sine x to the power of 6 plus sine x to the power of 8, close the bracket, with respect to x. Now, the difficult part is over. You can let u equal to sine x. And again, what that means is you can find a derivative. So if you're looking for du by dx, which means you want to find the derivative of u with respect to x, that's going to be cosine x, and du equals to cosine x dx. This is key. If I use a different color, look at this correlation, right here. So on the following step, I can rewrite this as du. And likewise, when I think about sine x, that will become u. So let's go back to the first color. Let's continue on the following page. So this means I can rewrite this as the following. And of course, I'm going to give you one more idea before I move on. Because I don't want to evaluate from 0 to pi over 2, you can also go back and say for x equal to pi divided by 2. This means sine of pi over 2. And again, you can take the calculator, you can do mental math. That's going to be 1. And the reason why we know that, by the way, is because when you graph y equal to sine x, you can tell, and again, this is x, of course, that is y. You can tell that sine of pi over 2 is exactly 1. And likewise, if you think about the lower index, when x is going to be 0, sine of 0, of course, would be 0. Again, it's this point right there. Or you can use the calculator in radian mode. Now, when you combine all this, the lower index is now a 0. The upper index is now a 1. And it's going to be the antiderivative of u to the power of 4 minus 2u to the power of 6 plus u to the power of 8. Don't forget, this is going to be du now because we're going to plug it in. Now, What happens when you find the antiderivative of u to the 4? That's going to be u to the 5 divided by 5. What about 2u to the 6? That's going to be 2u to the 7 divided by 7. And likewise, the antiderivative of u to the power of 8 is going to be u to the power of 9 divided by 9. You're going to evaluate this basically from 0 to 1. And really, it's from u equal to 0 to u equal to 1. And I'll put a bracket like that. Now, the rest of this I know you know. So I'm going to finish strong with you on the final page. You plug in u to be 1. You can plug in u to be 0, even though really the second bracket will become 0, but I just plug it in for now, just like that. And when you work it out, this is exactly 8 divided by 315. I hope this makes sense.